Now next one point is parameters of the covalent bond. कोव्हॅलंट बॉन्ड तयार करण्यासाठी जे वेगवेगळ्या प्रकारचे घटक आहेत पहा त्यांचा अभ्यास आपल्याला या ठिकाणी करायचा आहे. These parameters that help to understand how the strong bond between them between the two atoms and what is the distance between them and what is the shape of the molecule. हे जे पॅरामीटर्स आहेत त्यांचा उपयोग जो आहे that understand how the strong bond is between the टू atoms, दोन ॲटम मध्ये असलेला जो बॉन्ड आहे किती स्ट्रॉंग आहे, त्याचबरोबर व्हॉट इज द डिस्टन्स बिटवीन देम, त्या बॉन्ड मध्ये असलेले जे अंतर आहे हे पण आपल्याला लक्षात येतं. त्याचबरोबर व्हॉट इज द शेप ऑफ द मॉलिक्यूल, त्या मॉलिक्यूलचा शेप कोणता आहे हे सुद्धा आपल्याला ह्या पॅरामीटर जे आहेत कोव्हॅलंट बॉन्डचे याच्यावरून आपल्याला सहज लक्षात येतं पहा. त्यातला पहिला पॅरामीटर आहे पहा, फर्स्ट वन पॅरामीटर दॅट इज द बॉन्ड अँगल. फर्स्ट पॅरामीटर इज द बॉन्ड अँगल. इन a covalent bond, the electrons involved in a bond formation are present in a orbital. In a covalent bond जो तयार होतो तो इलेक्ट्रॉन जे असतात ऑर्बिटल मध्ये हे इलेक्ट्रॉन्स इन्व्हॉल्व टू फॉर्म द a covalent bond. Then now definition of the a bond angle is simple definition. The angle between the two orbitals, the angle between the two orbitals holding the bonding electrons is called the bond angle. The angle between the orbitals, orbital मध्ये असलेला angle that holding the bonding electrons, की ज्याच्यामध्ये काय आहेत, इलेक्ट्रॉन्स आहेत, त्या ऑर्बिटल मध्ये इलेक्ट्रॉन्स आहेत, is called as the a bond angle. The angle between the orbitals that hold the bonding electrons, that holding the bonding electrons, that is called as the a bond angle. This is the definition of a bond angle. The value of bond angle gives an idea. The value of a bond angle gives an idea about the arrangement of orbitals around the central atom and the shape of the molecule. The bond angle आहे that gives the idea about the arrangement of a orbitals around the central atom. Central atom जो आहे त्या सेंट्रल ॲटम मध्ये या ज्या ऑर्बिटलची अरेंजमेंट जी आहे ती कशा प्रकारे केलेली आहे, त्याचबरोबर शेप जो आहे मॉलिक्यूलचा तो सुद्धा आपल्याला बॉन्ड अँगलने आपल्याला लक्षात येतो पहा. द बॉन्ड अँगल कॅन बी डिटरमाइन्ड एक्सपेरिमेंटली बाय ए स्पेक्ट्रोस्कोपिक टेक्निक. बॉन्ड अँगल कॅन बी डिटरमाइन्ड एक्सपेरिमेंटली बाय ए स्पेक्ट्रोस्कोपिक टेक्निक. दिस इज द H2O molecule, H2O molecule, and that having a bond angle. This is the oxygen atom, the angle between the hydrogen, oxygen, the bond angle. This is the a bond angle. The definition I will repeat again. The angle between the orbitals, having the a bonding electrons. The angle between the orbitals having or holding the bonding electrons is called the a bond angle. Now some examples. First one, that is the H2O, bond angle is about 104 degree and 28 minutes, whereas in NH3 ammonia 107 degree, whereas in BF3 that is the a 120 degree. This is the examples of the bond angles. Now next one point is bond enthalpy. The definition of the bond enthalpy is it is the amount of energy required to break 1 mole of a particular bond. Present between the two atoms in the gaseous state. Simple definition है पहा, bond enthalpy. Enthalpy means energy. It is the amount of energy required to break 1 mole of a particular bond. एक मोल बॉन्ड जो आहे तो तोडण्यासाठी लागणारी एनर्जी प्रेझेंट बिटवीन टू ॲटम्स इन द गॅसियस स्टेट, की जे दोन ॲटम्स कशामध्ये असतील, गॅसियस स्टेट मध्ये असतील, and that energy is called as the a bond enthalpy or bond energy. The bond enthalpy of a diatomic molecule is equal to its dissociation energy. Bond enthalpy of a diatomic molecule ची bond enthalpy जी आहे is equal to its dissociation energy. And bond enthalpy is a measure of a strength of the bond between two atoms. Bond enthalpy is measure What it measures? It measures the strength of the bond between the two atoms. दोन atoms मध्ये असलेली जी strength आहे, that will be measured by bond enthalpy. Larger the bond dissociation energy, larger the bond dissociation energy, bond तोडण्यासाठी लागणारी energy, stronger is the bond. Bond is stronger. जेवढी जास्त bond dissociation energy लागेल, तेवढा तो bond काय असेल? Stronger असेल. In case of a polyatomic molecule, the bond enthalpy is the average of the sum of successive bond dissociation energies. In case of polyatomic, poly means many atomic or polyatomic molecule, the bond enthalpy is the average of the sum of successive bond of dissociation energies. For example, H2O, after dissociation of H2O, हा जो H2 आहे याचा बॉन्ड डिसोसिएशन करायचे, बॉन्ड तोडायचे पाहिजे ठिकाणी हा H2O. Suppose we are breaking this bond or this one. When we break down this bond, at that time that forms a H and OH. H and OH. That means they are undergo dissociation, and that requires energy. Our bond enthalpy is about delta H1 is equal to 502 kilojoule mole inverse. Whereas after dissociation of H2O, that form H plus OH. After dissociation of OH, पुन्हा या OH चं dissociation करायचं बा आपल्याला. OH that gives a H plus O. या ठिकाणी हा OH जो आहे, हा OH, हा बॉन्ड याचं dissociation झालं. That requires energy. Delta H2 is equal to 427 kilojoule mole inverse. Delta H2 जो आहे हा OH बॉन्ड तोडण्यासाठी लागणारी एनर्जी आहे बा किती ती 427 किलोजूल मोल इनवर्स. Then hence average bond enthalpy of OH bond is OH bond तोडण्यासाठी लागलेली average bond enthalpy. Then how to calculate average? Take an average. Delta H is equal to 502. This is the 502 plus 427 divided by 2. After division, we will get a average delta A, that means the average. A for average. Bond enthalpy of oxygen hydrogen bond is about 464.5 kilojoule mole inverse. 464.5 kilojoule mole inverse. This is the average bond enthalpy. For examples of the bond enthalpy is carbon hydrogen bond enthalpy is about 400 kilojoule mole inverse, whereas carbon double bond that requires 610 to 630 kilojoule mole inverse. This is the bond enthalpy, that means bond dissociation energy. Next one point is bond length. Bond length definition. It is the equilibrium distance between the nuclei of the two covalently bonded atoms in a molecule. It is the equilibrium distance between the nuclei of the two covalently bonded atoms in a molecule. दोन मॉलिक्यूल असतील, दोन ॲटम असतील, या दोन ॲटम मध्ये जे अंतर आहे, परंतु अंतर कुठलं? दोन न्यूक्लियस, फर्स्ट ॲटम आणि सेकंड ॲटम, या दोन्हीचा न्यूक्लियस याच्यामधील जे अंतर आहे, या अंतराला काय म्हणायचे? बॉन्ड लेंथ असं म्हणायचे. It is the equilibrium distance. Definition I will repeat again. It is the equilibrium distance between the nuclei of the two covalently bonded atom in a molecule मध्ये. Next one, bond length depends upon the size of atoms and multiplicity of bonds. Bond length कशावर अवलंबून आहे? That depends upon the size of atom and multiplicity of bonds. साइज जी आहे ॲटमची ती किती आहे, त्याचबरोबर बॉन्ड्स किती आहेत याच्यावर बॉन्ड लेंथ अवलंबून आहे. It is generally measured in a picometer or angstrom unit. It is measured in a picometer, em for picometer, and a naught, that is the angstrom unit. Bond lengths are measured by a X-ray and electron diffraction technique. Bond lengths are measured by X-ray and electron diffraction technique. Bond length जे आहे ते कशा सहाय्याने मेजर केली जाते? बाय X-ray and electron diffraction technique च्या सहाय्याने मेजर केली जाते. For example, oxygen hydrogen bond length is about 96 picometer, whereas carbon hydrogen is about 107 picometer, and hydrogen and chlorine is about 127 picometer, and also hydrogen bond length is about 74 picometer. These are the bond length of a particular covalent bond. Next one point is bond order. Next one point is a bond order. Here it is equal to the number of bonds between two atoms in a molecule. It is equal to the number of bonds between the two atoms in a molecule. Molecule मध्ये असलेले जेवढे atoms जेवढे bonds आहेत, that is equal to bond order. एखाद्या molecule मध्ये समजा suppose we are taking two bonds, then bond order is also 2. In a isoelectronic molecule, and ions have identical bond order. Isoelectronic molecule and ions have identical bond orders. For example, H2, F2, that having a bond order is 2. H2 असेल किंवा F2 असेल, that having a bond order 1, whereas H2, O2 and N2, that having a bond order 1, 2, 3 respectively. That is hydrogen having a bond order 1, also oxygen having a 2, and nitrogen having a 3 bond order. That means nitrogen having a triple bond, oxygen having a double bond, and hydrogen having a single bond. It stability of a molecule can be determined by knowing the bond order. Stability जी आहे molecule ची, that will be determined by knowing the bond order. As bond order increases, bond enthalpy increases. Bond order increases, that means number of bonds increases. Then bond enthalpy is increases, that means bond dissociation energy is also increases. Bond जो आहे हा तोडण्यासाठी लागणारी एनर्जी ती सुद्धा कशी असेल? वाढणार आहे पहा. And bond length decreases. And bond length काय होणार आहे त्या ठिकाणी? Decrease होणार आहे. This is the a bond order. In short, keep in your mind, number of bonds between the two atoms is equal to bond order. And next one point is a polarity of a covalent bond. Polarity of a covalent bond. Covalent bonds are formed between two atoms. Covalent bonds are formed between two atoms of the same or different elements. Covalent bonds are formed between the two atoms of the same or different elements. सारखे असतील किंवा वेगळे असतील atoms आणि त्यांच्यापासून काय तयार होतो? Covalent bond तयार होतो. A shared pair of electrons is attracted equally. A shared pair of electrons is attracted equally to both atoms and is present center between two atoms. The shared pair of electrons is attracted equally to the both atoms and is present center between two atoms, and that covalent bond is called as non-polar covalent bond. Non-polar covalent bond. Non-polar covalent bond कशा प्रकारे तयार होतो? A shared pair, दोन ॲटम मध्ये इलेक्ट्रॉनचं शेअरिंग होणार आहे पहा, घेवाण देवाण होणार आहे पहा, आणि that attracted equally about both atoms present at the center between the two atoms, and that covalent bond is called as non-polar covalent bond. इथे दोन atoms आहेत हायड्रोजन H2, यामध्ये जो बॉन्ड तयार झालेला आहे याच्यामध्ये हे जे इलेक्ट्रॉन्स आहेत हे इलेक्ट्रॉन्स कुठे असणार आहेत? that are present at the center between two atoms, center of the between two atoms. That means these hydrogen attracted electrons, also these hydrogen attracted electrons towards itself equally. Therefore, these electrons are these two electrons are present at the center of the molecule. Whereas when a covalent bond is formed between two atoms differing in electronegativities, the electron bond pair is pulled towards the more electronegative atom, resulting in a separation of charges, and this gives rise to a polar covalent bond or a dipole. Polar covalent bond or dipole. Dipole, di means two, two poles. That means positive and negative. या ठिकाणी पोलर कोव्हॅलंट बॉन्ड कशा प्रकारे तयार होतो, तर या ठिकाणी जो कोव्हॅलंट बॉन्ड तयार होणार आहे त्यामध्ये एक इलेक्ट्रॉन, एक ऍटम जो आहे तो मोर इलेक्ट्रोनिगेटिव्ह असेल, त्यावेळेस काय होणार आहे, the electrons are that are attracted towards the more electronegative atom and resulting in a separation of charges. त्याच्यामुळे काय होणार आहे, अट्रॅक्ट झाल्यामुळे त्यामध्ये चार्ज सेपरेशन होईल. त्या ठिकाणी काय होईल, चार्ज सेपरेशन. दॅट मीन्स हियर पोलर कोव्हॅलंट बॉन्ड हायड्रोजन अँड we are taking example hydrogen and fluorine. Here fluorine is a more electronegative atom that attracts the more electron towards itself. स्वतःकडे काय करेल, तो अट्रॅक्ट करेल आणि त्याच्यामुळे काय होणार आहे, या ठिकाणी चार्ज सेपरेशन होईल. Thus hydrogen carries the delta plus charge and fluorine having a delta minus charge. The more electronegative atom acquires a partial negative charge. More electronegative atom acquires a partial negative charge. Here more electronegative atom is fluorine that carries a partial negative charge, and less electronegative atom that carries that acquires a partial positive charge. This hydrogen is a less electronegative than fluorine, therefore that carries a partial positive charge, and charge developing a polar covalent bond. Due to charge formation that form a polar covalent bond, that is also called as a dipole. Di means two. More the bond polarity, stronger is the bond. More the bond polarity, जेवढा जास्त बॉन्ड जो आहे हा पोलर असेल, जेवढा जास्त बॉन्ड काय असेल पोलर, तेवढा तो बॉन्ड काय असेल, स्ट्रॉंग असेल. पोलर या ठिकाणी that form two charges or two poles, positive and negative. That is the polar. When the difference in electronegativities, when the difference in electronegativities of a combining atom is about 1.7 ionic percentage and in the covalent bond is about 50%. When a difference in electronegativities of a combining atom is about 1.7 ionic difference किती असेल, 1.7 असेल, किंवा ionic percentage जे आहे ते किती असेल, 1.7 असेल, whereas covalent bond formation is about 50%. And this is about the polarity of a covalent bond. One parameter of the covalent bond is dipole moment. Here definition of the dipole moment is defined as the product of the magnitude of a charges and distance between the central positive and negative charges. Dipole moment की definition काय आहे पहा, it is defined as the product of the magnitude of charge and distance between the center of positive and negative charge. And the formula is mu is equal to q into r. Formula is dipole moment formula is according to definition, mu is equal to q plus r. Here q is the charge and small r is equal to distance of separation of positive and negative center. दोन ऍटम मध्ये असलेले जे अंतर आहे, दोन पॉझिटिव्ह आणि एक पॉझिटिव्ह आणि एक निगेटिव्ह जो ऍटम असेल त्यांच्यामधलं जे अंतर आहे, that is the AR, and unit of the dipole moment is d by, which is denoted by capital D, whereas 1d is equal to 3.33564 into 10 raised to minus 13 coulometer. cm for coulometer, c for coulomb, m for meter. This dipole moment is a vector quantity. And this dipole moment is represented by a small arrow with the tail on the positive center. The dipole moment is represented as a small arrow. This is the small arrow, and direction दिली पाहिजे त्याची. The tail of the positive end, tail जे असणार आहे, हा arrowचा जो tail आहे, हा tail कुठे असणार आहे, या ठिकाणी पॉझिटिव्ह साइडला असेल, whereas the head of the arrow is directed towards a negative end, directed towards the or pointing towards the negative center. This is the HF molecule. Here the hydrogen is a less electronegative atom, whereas fluorine is a negative element, hydrogen is a electropositive element, and chlorine is a electronegative atom. Fluorine is a more electronegative atom, therefore this arrow is directed or pointing towards a negative side, that is the fluorine side, whereas the dipole moment of this HF molecule is about 1.91 dBi. 1.91 dBi. This is a dipole moment. Definition of the dipole moment is product of the magnitude of the charge and the distance between the center of positive and negative charges. This is a dipole moment. Next point is dipole moment of polyatomic molecule. Dipole moment of a polyatomic molecule. Here, in a polyatomic molecule, each polar bond has its own dipole. In polyatomic molecule, poly means many. Polyatomic molecule मध्ये काय होतं, each polar bond has its own dipole. त्याचा वैयक्तिक dipole असणार आहे and dipole moment. Since dipole moment is a vector quantity. Dipole moment is a vector quantity. As you know, this is the vector quantity. The resultant dipole moment of the molecule, the resultant dipole moment of the molecule is decided by resultant dipole moment of the molecule is decided by, first one is the shape of the molecule. Resultant molecule जो आहे, resultant dipole moment जे आहे, that decide what it decides the shape of the molecule. Also the second one, contribution of each dipole moment of a polar bond in the molecule. तो resultant dipole moment आहे moleculeचा, तो काय ठरवतो पहा, शेप ऑफ द मॉलिक्यूल. दिलेल्या मॉलिक्यूलचा शेप जो आहे तो कोणता आहे हे ठरवतो. त्याचबरोबर कॉन्ट्रिब्युशन ऑफ ईच डायपोल मूवमेंट ऑफ द पोलर बॉन्ड इन द मॉलिक्यूल. Hence, the resultant dipole moment of the polyatomic molecule is a vector sum of the dipole moments of the various bonds and lone pairs. For example, consider a BeF2 molecule. For example, BeF2 molecule. Here, this is a fluorine, beryllium, and fluorine. Here, this beryllium is a less electronegative atom, that is the electropositive, whereas this fluorine atom both are the electronegative atoms. What happened here? The more electronegativity is transferred from this beryllium to fluorine. This fluorine कडे काय होणार आहे, arrow indicate करेल पहा. arrowचं हेड जे आहे ते fluorine कडे असेल. इकडे सुद्धा काय असणार, हा इलेक्ट्रोनेगेटिव्ह असल्यामुळे ह्या arrowचं हेड जे आहे ते fluorineच्या बाजूने असेल पहा. In a BF2 molecule, it is linear molecule. It is a linear molecule, and the bond moments of the two beryllium and fluorine bonds are equal in strength, and opposite in a direction. But in a opposite in a direction. Hence, the net dipole moment of BeF2 is 0. Net dipole moment is a 0. या ठिकाणी फ्लोरीन काय करणार आहे, ते इलेक्ट्रॉन काय करणार आहे, स्वतःकडे ओढून घेणार आहे हा फ्लोरीन. त्याचबरोबर हा फ्लोरीन सुद्धा काय करेल, तो इलेक्ट्रॉन स्वतःकडे ओढून घेईल. आणि याच्यामुळे काय होणार आहे, नेट डायपोल मोमेंट जे असणार आहे ते काय असणार आहे, 0. हा इकडे ओढतोय, त्याचबरोबर हा सुद्धा इकडे ओढतोय. त्याच्यामुळे नेट डायपोल मोमेंट काय असणार या ठिकाणी, 0. Second one example is BF3. In a BF3, what happened here? Here also in BF3 molecule is a polar molecule. Here this boron having a electropositive charge, whereas the 3 fluorine atoms having a partial negative charge. Symmetrical, the BF3 molecule is a symmetrical trigonal molecule with bond angle is 120 degree. आता bond angle असणार आहे फ्लोरीन, बोरॉन आणि हा फ्लोरीन, bond angle is about 120 degree. And since in the 3 BF polar bonds, या ठिकाणी 3 बोरॉन आणि फ्लोरीनचे बॉन्ड तयार होतात. हा एक असेल, हा एक आणि हा एक. 3 फ्लोरीन बोरॉन फ्लोरीन bonds are oriented at 120 degree angle and with each other, and the sum of any two bonded moment is equal and opposite to third. Therefore, sum of 3 BF, that is the boron and fluorine dipole moment is a 0. Here this fluorine that attracted electron towards itself. Here also this fluorine attracted electron towards itself, and this also fluorine attracted electron towards itself. These are the negative terminals or partial negative charge that carry the partial negative charge, whereas this fluorine boron carries a partial positive charge. Due to that polarity, the sum of their boron fluorine bonds or dipole moment is 0. हा इकडे वळतोय, हा इकडे वळतोय आणि हा इकडे वळतोय पहा. त्याच्यामुळे जी डायपोल मोमेंट आहे या BF3 मॉलिक्यूलची ही काय असेल, mu is equal to 0. Next point is lone pairs and dipole moment. Lone pairs and dipole moment. In some cases, lone pair and dipole moment. Some cases, the central atom carries an unshared lone pairs of electron. काही मॉलिक्यूल मध्ये काय होते, सेंट्रल ॲटम that carries काय करतोय, that carries a unshared lone pair of electron. एखादा मॉलिक्यूल असेल आणि त्या मॉलिक्यूल मध्ये सेंटरला जो ॲटम असेल त्या मॉलिक्यूलवर काय असतात, अनशेअर्ड लोन पेअर ऑफ इलेक्ट्रॉन्स. एखाद्या मॉलिक्यूलवर इलेक्ट्रॉनची देवाणघेवाण होत असताना त्याच्यावर एक्स्ट्रा शेअर्ड न केलेले इलेक्ट्रॉन्स असतात, त्यांनाच आपण काय म्हणतो, लोन पेअर ऑफ इलेक्ट्रॉन्स असतात पहा. And these lone pair are also contribute to the resultant dipole moment of the molecule. These lone pair of electron also contribute. काय contribute करतात ते, to the resultant dipole moment of the molecule. Dipole moment जी आहे molecule ची, that will be contributed. For example, in a nitrogen in a NH3, that is the ammonia, and oxygen in a water having lone pairs. नायट्रोजन, अमोनिया मधला नायट्रोजन आणि ऑक्सिजन वॉटर मधला ऑक्सिजन, त्या दोन्ही मध्ये काय असतात, ऑक्सिजन वर लोन पेअर्स असतात, त्याचबरोबर नायट्रोजन वर लोन पेअर असतात. बट नायट्रोजन हॅज ओनली वन लोन पेअर व्हाईल ऑक्सिजन हॅज 2 लोन पेअर्स. या ठिकाणी नायट्रोजन जो आहे अमोनिया मधला त्याच्यावर एकच इलेक्ट्रॉनची जोडी असेल, whereas in ऑक्सिजन ऑफ द वॉटर मॉलिक्यूल that carries 2 lone pair of electrons. दोन इलेक्ट्रॉनच्या जोड्या असणार आहेत पहा, which result in the highest dipole moment of water. That means this water molecule having a highest dipole moment due to the presence of 2 lone pair of electrons. This is the structure of a ammonia molecule and this is the structure of H2 molecule. Here in nitrogen, here center atom is nitrogen, whereas this oxygen is here center atom is oxygen. This nitrogen which carries a single lone pair of electrons. This oxygen, this nitrogen carries a single lone pair of electrons. That means the pair of electrons. Whereas this oxygen which carries a 2 lone pair of electrons. 2 lone pair of electrons. And due to that, this oxygen having a higher dipole moment as compared to this ammonia, because the oxygen which carries a 2 lone pair of electrons. A second one example is NH3 and NF3. Second one example is the NH3 and NF3. Here this is the NH3 molecule and this is the NF3 molecule. Here center atom is nitrogen, here also a center atom nitrogen. These both nitrogen carries a single lone pair of electrons. Both have a pyramidal shape, both having a pyramid shape and with a lone pair of electrons on nitrogen atom. The resultant dipole moment of NH3 is about 4.90 into 10 raised to minus 13 coulometer, whereas in NF3 molecule is 0.18 into 10 raised to minus 13 coulometer. This difference between the two molecules having a same center atom is nitrogen, because in case of ammonia the orbital dipole moment is due to lone pair in the same direction. या ठिकाणी या ही तीन हायड्रोजन जे आहेत NH3 मध्ये हे तीन हायड्रोजन्स आहेत which carry the partial positive charge and that transfer the electronegativity towards nitrogen. Nitrogen is a more electronegative as compared to this hydrogen. Therefore electronegativity is attracted towards the nitrogen atom to the same direction as usual. But the resultant dipole moment of nitrogen hydrogen bonds, hence it gets added, whereas in NF3 The orbital movement is the direction opposite to the resultant dipole moment of 3 NF bonds. Here this is the NF molecule. Here these 3 fluorine atoms, and this carries these 3 fluorine atoms which carries the partial negative charge. Also this nitrogen is also carries a partial negative charge. Here that these electrons are attracted towards the 3 fluorine atoms. 3 fluorine atoms के काय होणार ते attract होणार आहेत पहा, and due to that resultant dipole moment is decreases. किंवा या ठिकाणी resultant dipole moment जो आहे तो कुठे होणार आहे, attracted towards the fluorine atom. इकडे काय होतं, resultant dipole moment that attracted towards the nitrogen. And this in NF3 molecule, the orbital movement is the direction opposite to the resultant dipole moment. Direction कशी असणार आहे, opposite. Here या साइडला पहा, here opposite side, and opposite direction to the resultant dipole moment. या ठिकाणी हा जो resultant dipole moment आहे त्याच्या opposite साइडला या ठिकाणी इलेक्ट्रॉन्स किंवा इलेक्ट्रॉन्स ट्रान्सफर होणार आहेत पहा of a 3 NF3 bonds. Now the third one example is methane, that is the CH4 and CHCl3. Here in methane molecule, central atom carbon and has no lone pair of electrons, and the molecule is non-polar. या ठिकाणी जो सेंट्रल आयटम आहे कार्बन हा कसा आहे, नॉन पोलर आहे पहा, आणि त्याच्यामुळे that having a no lone pair of electrons, and therefore it is non-polar molecule. Whereas in a CHCl3 molecule, there are a 3 carbon chlorine bond. 3 carbon chlorine bonds. 1, 2, 3 carbon chlorine bonds 3, and 1 carbon hydrogen bond. 1 carbon hydrogen bond. And their dipole moment are not equal, and therefore their dipole moment are not equal, and hence CHCl3 is a polar with a dipole moment is about 1.04 coulometer. Therefore dipole moment is a 1.04 coulometer. This is the this carbon, this is the chlorine atom. Chlorine is a more electronegative atom, therefore that attracts the more electron towards itself, here also, and due to that the dipole moment, therefore this molecule is polar molecule and dipole moment is 1.04 coulometer. Now next one point is covalent character of ionic bond. Covalent character of ionic bond. Ionic bond चा covalent character कसा आहे ते समजून घ्यायचं आहे आपल्या ठिकाणी. Many ionic compounds shows a partial covalent character. Many ionic compounds that show a partial covalent character. वेगवेगळ्या प्रकारचे ionic compounds आहेत आणि ते काय शो करतात, that show a partial covalent character. Partial covalent character दाखवतात पाहते, and exhibit the properties like a covalent compounds. आणि काय करतात ते covalent compounds ज्या properties आहेत तेच ते दाखवतात पहा. It is explained by a Fajans rule. That will be explained by Fajans rule. Fajans rule मध्ये काय सांगितले पहा, the smaller the size of cation, smaller the size of cation, larger the size of anion. जर cation ची साइज जी आहे ती कशी असेल, स्मॉलर असेल, आणि anion ची साइज कशी असेल त्या ठिकाणी ग्रेटर असेल, मोठी असेल. ग्रेटर इज द कोव्हॅलंट कॅरेक्टर ऑफ एन आयोनिक कंपाऊंड. त्यावेळेस काय होणार आहे, ते जो मॉलिक्यूल किंवा जो आयोनिक कंपाऊंड तयार होणार आहे त्याच्यामध्ये कोव्हॅलंट कॅरेक्टर कसा असेल, जास्त असेल. कधी जास्त असेल, जेव्हा स्मॉलर द साइज ऑफ कॅटायन and larger the size of anion. And for example, here we are taking 2 examples. This is the lithium chloride and this is the sodium chloride. Here this lithium carries a positive charge, chlorine carries a negative charge, sodium carries positive charge, chlorine carries negative charge. The smaller the size of cation, smaller the size of cation, cation ची साइज जेव्हा छोटी असेल आणि anion ची साइज जेव्हा मोठी असेल त्यावेळेस काय होणार आहे, ग्रेटर द कोव्हॅलंट कॅरेक्टर ऑफ एन आयोनिक कंपाऊंड. त्या आयोनिक कंपाऊंड मध्ये काय असेल, कोव्हॅलंट कॅरेक्टर कसं असेल, जास्त असेल. अँड ग्रेटर द चार्ज ऑन कॅटायन, greater the charge on cation. Here this lithium is a cation that having a positive charge, sodium is a positive charge. Here the cation having a smaller size, whereas anion having a larger size. And greater the charge on cation, more is the covalent character. एखाद्या कॅटायन वर जर चार्ज जास्त असेल तर त्याच्यामध्ये जास्त प्रमाणात काय असणार आहे, कोव्हॅलेंट कॅरेक्टर असणार आहे ऑफ अन आयोनिक कंपाउंड. कुठे? इन ए आयोनिक कंपाउंड. फॉर एक्झाम्पल द कोव्हॅलेंट कॅरेक्टर हियर इज Al3 plus Cl minus Al3 plus. This Al3 plus is a cation that having a charge 3 plus and charge या ठिकाणी जास्त आहे कोणापेक्षा? या मॅग्नेशियम 2 प्लस पेक्षा आणि ह्या सोडियम प्लस पेक्षा. म्हणून हा जो AlCl3 प्लस हा जो आहे, हा मॉलिक्यूल जो आहे, हा कसा आहे, याच्यामध्ये आयोनिक कॅरेक्टर या ठिकाणी कोव्हॅलेंट कॅरेक्टर कसा असणार या ठिकाणी जास्त असणार आहे कोणापेक्षा? या MgCl2 पेक्षा किंवा या सोडियम क्लोरीन पेक्षा, सोडियम क्लोराइड पेक्षा. 3 plus 2 plus and single plus. Therefore the more covalent character, greater the charge on cation, more is the covalent character. And a cation with a outer electronic configuration, ज्या कॅटायनच्या outer electronic configuration मध्ये S2 P6 and D10 इलेक्ट्रॉन्स असतील पहा. S मध्ये 2, P मध्ये 6 आणि D मध्ये 10 इलेक्ट्रॉन्स असतील. At that time that possesses a greater polarizing power than cation having a outer electronic configuration of S2 and P6 electrons having same size and charge. Same size and same charge. Here this S2, P6 and D10 having a greater polarizing power than a S2 and P6 electrons that having a lower polarizing power. Last one parameter of the covalent bond is resonance. Here many polyatomic molecules can be represented by more than one Lewis structure. Many polyatomic molecules can be represented by more than one Lewis structure. या ठिकाणी पॉलीएटॉमिक मॉलिक्यूल असेल तो वेगळ्या प्रकारे आपण लेविस स्ट्रक्चरच्या सहाय्याने इंडिकेट करू शकतो किंवा रिप्रेझेंट करू शकतो. Each structure differ from the other only in position of the electrons without changing the position of atoms. Each structure differ from or different from other only in the position of electrons without changing the position of atoms. Here the example is CO3 2 minus. CO3 2 minus. Here these are the resonating structures. These are the resonating structures of the CO3 2 minus ions. Here difference is that in these three structure difference is that the position of double bond position of double bond is different. That means the position of electrons is only different. Position of double bond or position of electrons is different, but the position of atom is remains same. Position of atom is remains same. None of this individual structure explain the properties sufficiently. None of this individual structure, या ठिकाणी जे स्ट्रक्चर काढलेले आहे हे सगळे स्ट्रक्चर यातलं एक स्ट्रक्चर घेतलं that does not explain a properties of the molecule sufficiently. एक स्ट्रक्चर घेतलं तर ते स्ट्रक्चर यातलं कोणतेही स्ट्रक्चर घ्या त्यातलं कोणतेही स्ट्रक्चर that cannot explain properties sufficiently. The actual structure of CO2 minus is a contribution of 3 Lewis structure and it is called as resonance hybrid. हे जे स्ट्रक्चर आहे CO3 minus structure, this structure is a contribution of 3 Lewis structure. 3 स्ट्रक्चर मिळून काय तयार होणार या ठिकाणी CO3 minus स्ट्रक्चर तयार होणार आहे पहा, and that is a resonance hybrid. This is the resonance hybrid. Resonance signifies that there is more than one possible arrangement of electrons around the atoms in the molecule or more than one Lewis structure, and these are called as canonical structures. Here these are the canonical structures or resonating structures. यांना काय म्हणायचं आहे? Canonical structure किंवा resonating structure. And these are here, these in between the two canonical structure there is presence of double-headed arrow. Double-headed arrow. And these are the canonical structures or resonating structures and is equal to the resonance hybrid. ह्याचे जेवढे कॅरेक्टर्स आहेत, या तीन स्ट्रक्चरचे कॅरेक्टरिस्टिक्स आहेत, तेच काय असणार आहे? इज इक्वल टू द रेझोनन्स हायब्रिड. नाउ अनदर एक्झाम्पल इज O3 minus. Here in that O3 minus, the three oxygen atoms. Here bond length is about 121 picometer and bond length single bond is about 148 picometer. And another structure of resonating structure, here double bond is here. Now here the bond length is about 148 picometer and here double bond length is about 121 picometer. Now these are the resonating structures or canonical structure, and this is the resonance hybrid. Here the three oxygen atom bond length between two oxygen atom is about 128 picometer, and also this bond length between two oxygen atom is 128 picometer. This is the resonance. Now next one point is resonance energy. Next point is resonance energy. Here many polyatomic molecule, वेगळे अनेक polyatomic molecule असतील पहा, or ions can be represented by different resonating structures. Polyatomic molecule मध्ये किंवा ions मध्ये that are represented वेगळ्या प्रकारच्या रेझोनेटिंग स्ट्रक्चर्स मध्ये किंवा वेगळ्या प्रकारच्या कॅनोनिकल स्ट्रक्चर मध्ये नुसार ते दर्शवले जातात पहा. अँड ईच हॅव्हिंग ए डिफरंट एनर्जी. प्रत्येकाची एनर्जी जी असणार आहे या प्रत्येक रेझोनेटिंग स्ट्रक्चरची किंवा कॅनोनिकल स्ट्रक्चरची एनर्जी कशी असणार आहे? वेगळी असणार. द एनर्जी ऑफ द रेझोनेटिंग स्ट्रक्चर इज डिफरंट दॅन एनर्जी ऑफ द ए मोस्ट स्टेबल स्ट्रक्चर ऑफ ए रेझोनन्स मोस्ट स्टेबल स्ट्रक्चर आर रेझोनन्स हायब्रिड. या ठिकाणी हे जे रेझोनेटिंग स्ट्रक्चर दाखवलेले आहेत, दीज आर द रेझोनेटिंग स्ट्रक्चर्स इज डिफरंट दॅन एनर्जी ऑफ द मोस्ट स्टेबल स्ट्रक्चर. या रेझोनेटिंग स्ट्रक्चरची एनर्जी जी असणार आहे किंवा कॅनोनिकल स्ट्रक्चरची एनर्जी असणार आहे त्याच्यापेक्षा या रेझोनन्स हायब्रिडची एनर्जी कशी असणार आहे? या ठिकाणी वेगळी असणार. दीज आर द रेझोनेटिंग स्ट्रक्चर, दिस इज द रेझोनन्स हायब्रिड. या दोन्हीची एनर्जी कशी असणार आहे? वेगळी असणार आहे. And the difference in energy of the most stable resonating structure, the difference in energy of the most stable resonating structure or resonance hybrid and different resonating forms is called as a resonance energy. Resonance energy ची definition काय दिलेली आहे पहा? It is the difference. कोणामधला difference आहे? It is the difference in energy of the most stable resonating structure, that is the resonance hybrid. It is the energy difference between the most stable structure, that is the resonance hybrid, and different resonating structure. And different resonating structure is called as a resonance energy. Resonance energy. In that way, we are finishing the chapter, that is a chemical bonding. Thank you.